Hello everybody, a new room, new technique. Hopefully this works now. What have we done? Last week we started with the so-called magic square, the different macroeconomic aims in economic policy. And in general, we find there are four different aims: steady and appropriate economic growth, price level stability, high level unemployment, and our relationship to overseas viewed with an external balance. And we started with steady and appropriate growth that we want to try to measure overall prosperity of an economy via the growth rate of real GDP. And what do we understand by real GDP? Well, when we defined gross domestic product, there we said that we value every goods and services with the market prices. Well, and this means just in a situation like we have it now in Europe with inflation rates between 5 and 10%, that if nothing else changes, so if we do not produce anything else, that we would have a growth rate of 5 to 10%. Because GDP is nothing else than P1, X1, P2, X2, P3, X3, and so on, with all here actual prices. Well, but would we then say if we do not produce anything else, but only prices are changing, would we then say that we have a prosperous situation in an economic way in our country? Well, not, and therefore we want to try to get rid of this price effect. And for this, we value every production of the actual year with the prices of the former year. And this is then defined in a so-called chain index. And there we have in the denominator GDP of the actual year valued with the prices of the former year divided by production in the former year valued with the prices of the former year. And this you see here, these are the quantities in the actual year, and these are the prices in the former year. And then this is chained by multiplication with the real index of the former year. Well, and there we can ask, if I go always 1 year back, how do I obtain then the index of the real index of the former year? Well, this is done that we just set 1 year fixed at 100. But this doesn't matter for the purpose we define this, because we are actually not that much interested in the absolute value of real GDP, but in the relative change of real GDP. And fixing at 1 year the index of real GDP to 100 does not change the growth rates. Okay, and then we can define the growth rate by just the change in real GDP relative to real GDP of the former year. And with this definition, then we can also calculate the price effect, because after we have the real growth rate, of course, we are also interested, well, if I look at nominal GDP, what is the amount of the price effect? And this is done by the GDP deflator, and GDP deflator is nothing else than that we calculate nominal GDP over real GDP. And the price effect, oops, this shouldn't happen. And the price effect is then given by the relative change of GDP deflator. Well, all this sounds very theoretical, and therefore we started last week to calculate one example, a very simple example, that we say we have just a two goods economy, and we know the price development, we know the quantity development of both goods, and for this we started to calculate nominal GDP. Nominal GDP was just the sum of prices times quantity. Then we can calculate the index of the nominal GDP. When we set, for example, 2016 to 100, then we have 520 over 490 times 100 is then the index of 2017, and so on. And well, the growth rate is just then the change in nominal GDP, 106.12 minus 100 divided by 100 is 61.12%. Well, and now we are at the interesting point, because now we want to calculate real GDP. And, oh, I have to open the chat. Is there something wrong? On the left. Okay, I see. Now it should be better. Thank you. So now, and this I will also do with you then parallel in Excel. Let me already move this in here. So what do I have to do in order now to calculate real GDP? Is it possible to calculate real GDP in the year 2016? If we go to the definition, what do I need? Quantities of today and prices of yesterday. No, because I do not have the prices of 2015. But you see here, since in the next step, in order to calculate the index, I need the real index of the former year. We see here that we just set index of 2016 to 100. So in this case, this is then 5.6. What do I have to do? I have to take the quantities of 2017 times the prices of the former year. So we obtain 0.9 times 100 plus 2 times 210, and this is then, I think, 510. Well, and this I just do for every year. So equals to 0.9 times 100 plus 2 times 210, 510, and then I just copy this downward, and if you click in here, then you see that also what I'm calculating is just highlighted. So in the next line, 1 times 120 plus 2 times 220. So 560 and 653. 560 and 653. Well, and now in order to obtain the real index of 2017, now I go just to my definition. What is this real index? Well, here I have the real index. Here I have the real GDP, in my case of 2017, divided by nominal GDP of the former year, 2016, times the real index we set for 2016 to 100, and then we obtain the index for the next year. Oops. Here we are. So this is the index of the former year, 2016, 100 times real GDP of 2017, 510, over nominal GDP of the former year, 490. So real GDP of 2017 nominal GDP of 2016, and this is the index real GDP of 2016. Up there. So this is equal to 100 index 2016 times real GDP 2017 over nominal GDP 2016. Well, and this we also can then just copy downward because it just shifts always only 1 year in time. So 104.8 104.08 and 112.09 and 119.99. 112 point, what was it? 09 and 119.99. Well, growth rate 2016 is not possible because we do not have real GDP of 2015. What is the growth rate in 2017? Growth rates are always defined in the same way. What is the growth of profits? What is the growth of costs? What is the growth of what else? Revenue? Yes. Yeah. Yeah. Yep. Yeah. And this we can do in our head, so it's 4.08%. Yeah, but it's good that you say this because if the numbers are not that easy, then you have really to recapitulate the definition. Okay, so here we have 4.08%, and this is then 8, 100, 4.08 minus 100 over 100. But for my purpose, this we can, manipulate a little bit, and then sometimes if you want to do this in Excel, then it is quite faster how you can, in quotation marks, program it. You can also just write this at 104.08 over 100 minus 100 over 100, and this is then minus 1. And this is maybe also quite good to know. This is then called the growth factor. And the growth rate is just the growth factor minus 1. Maybe if you had some lecture on investment or something like this, and you were talking about interest rates, then if you invest, for example, 1,000 euros with 3%, then you know that you earn an interest of 30 euros, but your capital in the next year is then 1000 plus this 30 euros, so 1030. And this is just by multiplying the your invested capital of 1000 euro times the growth factor. And the growth factor is 1.03 if you have 3%. And this is sometimes quite good to know because then you can do the calculation quite faster if you remember this. So maybe we write this also down. This means growth rate equals growth factor minus 1. Okay, and since always growth rates are defined in the same way, I, in this case, can just copy this formula here, the growth rate of nominal GDP, copying this formula just here. If I click on this, you also see 104.08 minus 100 over 100. So putting this downward, we obtain 7.69 and 7.05. 7.69 and 7.05%. Well, now we have here the nominal growth rates. Here we have the real growth rates. And then we're also interested in the price effect. And for the price effect, we at first calculate the GDP deflator. How was the GDP deflator defined? The GDP deflator was just real GDP over nominal GDP times 100. The number 100 here is just a definition because always we want to have an index in the neighborhood of 100. So this is actually no mathematical implication. So, oops. In this case here, it is very easy. This is just 100 since this is our basis year. And we defined the other two values by 100, then of course the GDP deflator is also 100. So 9 is, oops, 9 then we have 100 over 100 times 100 is of course 100. Well, maybe that you remember this in a better way. I also make the example in the next case. There we have, oops, 166.2 over 104.8 times 100. So nominal index over real index times 100. So then we obtain 106.12 over 104.08 times 100, and this I will do again here. There, I had it already. Oops. This is equal nominal index over real index times 100. Oops, this is the wrong one. So 100. So 101.96, 101.96, 111.06, and 118.55. Well, and again, then the price effect itself is the relative change of nominal GDP. So in this case, we obtain here 1.96%, 11, 101.96 minus 100 over 100 equals 1.96%. And this also just in Excel. Again, it's a growth rate. I copy this formula on the right and I'm ready. 8.93 and 6.74. 8.93 and 6.74. And this would be then the price effect. Well, what else can we do? Let's pose the question. What is average nominal growth of GDP from 2016 to 2019? Let's take this in red. So, how would you do this? Here we have the three growth rates. What is then the average growth rate? Because quite often, especially if we have such turbulent times like in the last 10, 15 years, every 3, 4 years, a huge crisis. So growth rates are very volatile. And then we are interested, well, what is the average performance of our year, of our country in the last decade, for example? Also, if you go to the stock market, and there you, of course, have ups and downs in the prices, so different yields of your stocks, and there you, of course, are also interested in the average performance, especially if you want to compare an investment at the stock market with an investment in some investment with constant interest. So if you, for example, invest in government bonds. And for this, it should be possible for you to calculate average growth rates. Hopefully, you have done something similar in statistics or mathematics. Well, since in economics we really very often talk about growth rates and then also about average growth rates, average interest rates. An interest rate is nothing else than a growth rate. Okay, so you're yeah. So then let's do it. Is average growth rate then 6.12 plus 17.31 plus 14.26 divided by 3. Yeah, this is your idea. Well, I just sum up all growth rates divided by the number. So let's see what happens. So then I take here the sum and divide this by 3 over 3 is 12.56. Applying this growth rate, what should then happen? Well, starting at 100, taking 3 times this growth rate, I should end up at 142.24. Or if this is the average growth rate, I should end up at the same point. Yeah, then let's see. If I'm always growing with the same growth rate, this would be then, let's take this here, 2017, 2018, and 2019. Oops. This would be then starting at 100 times 1 plus our growth rate is our growth factor. This would be then the number in the next year. Oops. I have to fix the growth rate here. Unfortunately, I'm only at 140. So, but 100 times 1 plus 12.56%. Well, applying the 3 times in a row means just writing this by the with the power of 3. Of course, okay? Because we have 3 years, yeah. So, but then we end up at 140.13 is not equal to 442.24. So actually, we see here already the problem we have, because what we need is, in order to average our growth rate, is we ask what would be the growth rate applying 3 times in a row that starting from 100 we end up at 142. So the thought experiment is 100 times 1 plus x This is the unknown average growth rate applied 3 years in a row. So up to 100, up to the power of 3, that this is 142.24. Well, and now solving this for x means that we obtain x equals 142.24 over 100. Then on the left side we have 1 plus x to the power of 3. To get rid of the power of 3, we have to take the third root, or rising to the power of 1 over 3. And then we have only 1 plus x on the left side, so minus 1. Well, and now we look at this part, and this I can write in another way. This I can also write as 142.24 over the index of nominal GDP of 2018. So this was 129.49 times 129.49 over the index in 2017, 106.2 times 106.2 over the index in 2016, 100. So why? Oh, sorry, this you can't really see. Then I have to. Can they see this afterwards in the video? So why did I do this in this complicated way? Well, what is this? What is this? And what is this? Remember what I wrote here. 10408 over 100. Well, this was here with the real index. So this is then the growth factor of nominal GDP of 2016. Okay? So these are the growth factors of nominal GDP of nominal GDP of the years 2017, 2018, and 2019. Oh, this is not seen anymore. So this I have to put up a little bit. So and this you have hopefully already seen in statistics or mathematics, because what we have here is growth factor 217 to 18 times 219, taken the third root. This is nothing else than the geometric mean of the growth factors. Well, and this is always the case. If you want to average growth rates in order to be mathematically exact, you have always to calculate the geometric mean of the growth factors and then minus 1. And you cannot take just the arithmetic mean. The arithmetic mean is only an approximation, but you can keep in mind this approximation is only valid if you have roughly growth rates or interest rates below 10%, because then your error is somewhere in the third, fourth digit or so. But if you have, as we have it here in this case, growth rates larger than 10%, then you will have also a large error if you take the arithmetic mean. So then average growth rate equals 2. Let's calculate this. That we take here the growth factors. Nominal GDP growth factors in 2017, 18 and 19. Let's reformat this. Oops. So we obtain here 106 over 100. And then multiply this. And then we obtain average growth rate by this times this times this to the power of 1 over 3 minus 1. And in order to take this in percent, then we have here an average growth rate of 12.46. And you see that we directly have in the first digit our difference in the growth rate. And this is 12.46%. And this is mathematically exact. Well, I'm quite often talk about this because in many books you will find only that take the arithmetic mean in order to average. Quite often this is okay, but please keep in mind this is only possible if the growth rates are lower than 10%. Well, and actually if you go to the stock market and you're calculating yields at the stock market, you quite often have ups and downs of 20, 25, 30% or something like this. Also, profits can jump quite fast. So in many cases, you have a time series where the relative change is larger than 10%, and then you should know that averaging with the arithmetic mean is not correct. And how do we see this too? Is in this case also nominal GDP growth rate 17%, real GDP growth rate 7.7%. So we cannot just subtract this 17.3 minus 7.7 and we do not end at the price effect. And this is also the case because in my example here, I have relative changes larger than 10%. Please keep this in mind. We will do some other examples for this, and sometimes in an exam I also pose the question, please calculate mathematically exact. So have a look at this averaging process via the geometric mean. Well, since I also told you that you are allowed to use Excel, we have also a formula for this. So geometric mean of these three numbers minus 1 is of course then the same. So if you click in here, up, where is it? There. So of course you have here a formula, and of course you have also here a formula. Oh, this is not right now. Back. That also for the arithmetic mean we have also directly the formula. But please start to use Excel because you will need it in your job later on, definitely. And if you then already practice not only typing in numbers, but also using the simple formulas you have, then you will have a comparative advantage. Okay. So, of course, here. Done. Let's start to look at the time series again for Germany. Well, what we then see is, since the introduction of the euro, 99, in Germany, is just that you more or less always see nominal growth is in general larger than real growth. So in general, we have a positive price effect. This means in general, we have a positive price effect. Well, later on, when we are talking about price stability, we will also see that actually our aim is to establish a positive price effect and not an inflation rate of 0. And why? And the reason for this we will talk later on. Well, and here you see this dramatic difference between nominal growth and real growth. So in the last year in Germany, we had a nominal growth of roughly 7%. Well, will we therefore then say that we were in a very prosperous situation? Of course not, because everybody, when we went to the supermarkets and saw what we have to pay, we didn't think that it is a really nice situation. Okay, and here is then the relative change in GDP deflator, and this is then more or less the difference between the blue and the orange line in this case, and here again you see this dramatic change in the actual situation. So, in order to summarize this, nominal GDP represents changes in prices and quantities. The relative change in real GDP represents only the changes in quantities, and therefore this is our parameter when we are looking at what is economic growth. And when we then know the relative change in GDP deflator, then we have directly the dependence between real GDP and nominal GDP. And in order to close, since I also gave you here in the beginning that although we mostly we mostly talk about change in real GDP when we talk about economic growth, we have also to keep in mind that the economic situation in a country can highly change via migration, via population growth. I give you here two when we take real GDP and real GDP per capita. And what we see more or less is for Germany until 2014, population was almost constant, and therefore there was no difference, or there was almost no difference between real GDP growth and real GDP per capita growth. But then, due to migration and refugees, especially in 2015 and 2022. This is Syria and this is Ukraine. We had a large difference. So this is then here almost real GDP growth per capita was half of the real GDP growth, and also in 2022. And this, of course, we always have to keep in mind in order to interpret our growth numbers. Well, and also, if we take now the dramatic situation in Israel and at Gaza, we should not be surprised if there will be new waves of refugees coming to Europe. Okay, done. 15 minutes left, so let's also start with the next aim, price level stability. And we had already calculated here a price parameter, namely the GDP deflator. But if we talk about price development in a country, if we talk about inflation, in general, we calculate for this the so-called consumer price index, or since we have one currency within the European Monetary Union, there again, similar to the harmonization of how we calculate gross domestic product, we also harmonized the calculation of consumer prices. And for this, we have then the so-called HCPI, harmonized consumer price index. And if you then have a look, for example, to the statements, press statements of the European Central Bank, and they say maybe, yeah, we are convinced that prices are coming back, going down again. Their focus is then the so-called HCPI. But if you look at the news in Germany and you read about what is inflation in Germany, then usually the focus is on the so-called consumer price index. Well, they do not differ that much, but you should know that these are different price indices. Yeah, and then what do we define as price level stability? And for this, we have a definition by the European Central Bank. So the European Central Bank considers price stability is best maintained by aiming an inflation of 2%. And now this is important, over the medium term. So this means that it is also possible that the inflation rate fluctuates a little bit around 2%. Inflation rate is calculated via the this has to be HC. CPI. And what is also important, fluctuations over and under 2% are valued symmetrically. So if we have higher inflation, this is as bad or as good as if we have lower inflation. And this is, yes, a change. It was changed in 2019. And until 2019, the definition of price level stability was also 2%, but it should always be a little bit less than 2%. Well, and why did we change, or why did the ECB change these price level stability definition? Well, if we go back in time, after the financial crisis, we had a very long period with very low inflation rates. So later on, we will talk about monetary policy. European Central Bank tried almost 10 years to obtain higher inflation rates, and this didn't happen. And then in the year 2021 and 2022, inflation rates exploded. Okay, but let's talk about the reasons why. What is the reason that we want to have price level stability? Because in general, remember your other courses, in general, because in general, we want that prices come out of a free market process. Remember again just our diagram with supply and demand. And there we say, well, go to the market and then we obtain some price. And this means, of course, that prices on a free market can jump, can fluctuate. But what is then from a macroeconomic perspective are the reasons? Well, if prices are, or if the fluctuation of prices is too much, if we have very high fluctuations, so that we do not have any idea where are the prices tomorrow in general in our economy, then the signal which we want to have from prices, that prices just a signal of scarcity of goods in order to solve the general economic problem. Which goods should I produce for our society? And then we would lose this signal of scarcity if prices are always jumping, are always very volatile. So the aim is not that every prices are more or less constant or change only with 2%, but in general that we say the price level, the overall price level in an economic in an economy should not fluctuate that much because, well, let's take just the actual situation when we had inflation rates of 10% and more. Then, of course, it started a situation of uncertainty. What should I really do with my money? Because I do not know roughly how much money I have to spend, especially for things like food tomorrow. And this means price level stability is then something like an insurance against uncertainty of tomorrow. And of course, well, if prices especially are changing or inflation is very high, then this means that the value of money is going down over time. And this also means, remember the circular flow, we need the savings for the tomorrow investments. And if I think that tomorrow the value of my money is much less than today, then the savings are going down. And if the savings in the long term are going down, also my investment goes down. And this is also not good for our economy. So preservation of value of money. And of course, if always prices are changing, then I always have you to inform that prices have changed. So I have classical transaction costs. Well, in a digital economy, it is not. This is not anymore the main problem. But if we go back in time, then you always have to print now new price signs when prices are always changing, and therefore this is called the so-called menu costs. If you always have to make new price declarations. Well, related to this preservation of value of money means also that somehow we have something like an injustice between the creditor and the debtor. Because what is the creditor doing? He is giving you today, so to speak, good money. With high inflation rates, you are repaying your credit with money which is less worth. Well, and this is of course then the reason that in situations with high inflations, the interest rates will go up. Well, and about this I also already talked. Well, in a macroeconomic point of view, it is a general aim that I know that I have stable investments or aggregate investments over time, that I can really calculate with an amount of investment. And if I have highly fluctuating prices, then this situation of savings and investment will be also quite volatile. And uncertainty and highly volatile decisions are, of course, in the aggregated situation or is in the aggregated way a bad situation for the economy as a whole. And therefore, we have, of course, some good reasons to have this aim of price stability in general. Yeah, and then on Thursday we meet again. We will do something similar we have already done with our GDP, because now we have qualitatively and generally talked about prices, and now we want to talk about, well, how do we actually measure prices? So how do we calculate inflation? What is the CPI? What is the HCPI? And then in the end, we will also make a little example where we calculate an inflation rate. Okay, then thank you very much for today and see you on Thursday.